Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 1. We're on question number 20. So this question asks us if we have a rectangle inscribed in a semicircle of radius A, what's the maximum area that this rectangle could have? So it helps to draw a picture here. Let's draw a picture. Let's do something like this. We've got the x-axis and the y-axis. A semicircle, let's draw a semicircle whose center is at the origin and whose radius is a. So this is going to be a and minus a. It's going to look something like this, more or less. Not a very good picture of a semicircle, but it'll do. Now, if we draw a rectangle that's inscribed in the semicircle, it's going to touch the semicircle at some points, and it's going to look something like this. So if this point here is x, then the y coordinate here, remember that the radius of the semicircle is a, so our y coordinate is going to be, this is x, and the y coordinate, according to the Pythagorean theorem, is going to be the square root of a squared minus x squared. Okay, and so then our area, the area function, is going to be, well, length times width. What's our length? Our length is going to be 2x because the length is x, and then here's another. Right, so this is x, and this is also x. So it's going to be 2x times the width, which is just our y coordinate. So that's going to be square root of a squared minus x squared. And to find the maximum of this function, we have to take the derivative. So our derivative is going to be, we'll use the product rule here. The derivative of 2x is 2 times the square root of a squared minus x squared plus 2x times the derivative of the square root of a squared minus x squared. We're going to have to use the chain rule, so that's going to be 1/2 a squared minus x squared to the negative 1/2 times negative 2x. Now, remember, to find the maximum of this function, we're going to have to set the derivative equal to 0 and solve for x. So let's see. If we move this here, I'm going to set this equal to 0. Okay, so if we factor out this a squared minus x squared to the negative 1/2, here we have a squared minus x squared to the positive 1/2, we can write that a prime of x is equal to a squared minus x squared to the negative 1/2, and times 2 times, well, if you factor out a squared minus x squared to the negative 1/2, then you're going to have an a squared minus x squared to the 1 power left over. You can check that. Plus, well, this 2 and this 2 cancel out, and we have x times negative 2x. So that's actually going to be minus 2x squared. And we can't really factor out the a squared minus x squared to the negative 1/2, so that's gone. And we're setting all this equal to 0. Now we have a product that's equal to 0, so we have to check each factor. Now this factor, a squared minus x squared to the negative 1/2, that's not going to equal 0 because it's 1 over some number. And so we have to check when this is equal to 0, and let's see, if we write it out, we get 2a squared minus 2x squared minus another 2x squared equals 0. Well, that gives us 4x squared equals 2a squared, or x is equal to, let's see, a divided by root 2. So that's our x. So now our area that's the x that gives us the maximum area. So to find the maximum area itself, we're going to have to plug this into our area function. Remember, this is our area function here. So our area function of a over root 2 is going to be 2 times a over root 2 times the square root of a squared minus x squared, which is a over root 2 squared. So a squared over 2. Well, what does that give us? Let's see, 2a over root 2 times, well, this part is just going to be a squared over 2. And take the square root of that, gives us another a over root 2. So notice that x and y are actually the same. And so this gives us 2a squared over 2. The 2's cancel out, and the answer is a squared, which is C.